So you look at this screen. What is really a supercomputer? Chief guest already mentioned what is really a supercomputer. It's in high speed and as well as high memory configuration compared to our normal computer systems. As you know, our personal computers has a limited memory as well as RAM. That is, you know very well of our machine configuration. 1 TB hard disk and maximum 32 GB RAM as of now. Maybe okay. You may be at 64 GB RAM, etc. Even SSD technology, RAID, etc. So later on I'll connect all these terminologies relevant to the topic. Actually, the supercomputers having enough amount of computing power to solve the real-time problems. That is the purpose of supercomputers. Until otherwise, it is not required. So, SAS listed out some 5 important social or public-related applications such as precision agriculture, that is online medicines, that is timing, whatever, even smart transportation, everything integrated with IoT with cloud. So all are integrated with this along with AI and ML. So if you are going to come up with an automated system, then we need a supercomputing power. That means high performance computing. So supercomputer, quantum computers, parallel computers, distributed computers, cloud computers, even SAR said about that means the older classical brick computers, all are fall under high performance computing. Okay? You see, the supercomputer is a broad term for one of the fastest computer currently available. So you mentioned about quantum. In future, we are going to realize it definitely. So as of now, the supercomputers are designed and built to work on extremely large jobs, which are already listed, such as real-time problems, such as climate research predictions, disaster management, and then smart systems, that is smart cities, and wherever you are going to apply smart transportations, and then even we are in PMC of Tirunelveli smart cities, particularly project under SCADA and ICCC. So later on I will come up with that. Purely sensor-based systems, fully automated, without any human interaction. The system will gather the data through the sensors, and it will come up, that is fall under this high performance computing category, process the data, and it will instruct the officers and as well as laymen what to do next or further. That is a motto of that those projects, SCADA and ICCC. We are the PMC, we are happily finished off that project under Tirunelveli Smart City Corporation. So, why do we need for supercomputers? You see, our world is changing rapidly and the human has created an enormous database. Right now we are dealing the data in the form of, even we already reached TB, terabyte. Then next level is peta, exa, zeta, and so on. 10 to the power of 21. Just for your imagination. And simply for your understanding purpose, it's in big data. Am I right? For one simple example, I want to discuss about this big data. I think, whoever is sitting in this gallery, they should have a smartphone. Am I right? Everyone. Do you know the sensors, the number of sensors of your smartphone? Any idea? At least numbers. Clue 1 to 10. 7, 6, anything. Any idea? Minimum sensors. Sorry? I need your interaction. Otherwise, I will come up with the answers. Scopic sensor, touch sensor, GPS, then Wi-Fi, infrared, yes, proximity, thank you. 6, yes, fingerprint sensor, touch sensor, motion sensor, Anything else, please? Yeah. For what purpose? Yes, pressure. Gyroscopic or direction. Alright? Thank you. Navigation purpose. Right. With that only, the GPS is connecting. Right. Okay, we'll go for some, 10. Right. I don't want to go for listing all the sensors for your understanding. Because we people are using technology, but we are not aware of those sensors. And even the layman is asking about, sir, I didn't get the money while I'm doing transaction. What is the error? Even you are also repeating, I don't know. The same error only we face. Right? Then what's the difference between that educated and illiterate? Please see how to understand and map your theoretical concepts with real-time examples. That is the only part we are lagging. But we are studying those concepts in the theory part. Only the thing is mapping. So understand and then mapping with your real-time problems and real-time examples. You will never forget about those concepts. This is my experience as well as suggestion to you people, because I am not in a position to advise to you people. You are also not in a position to get advice from others. Thank you. So you imagine the 10 sensors from everyone's mobile phone. If you are connecting with internet, each and everyone's smartphone is generating 10 data per minute. Imagine 24/7 how many number of data which is generated by our smartphone and it is gathered by server. So you imagine national wide, that is country wide. As of now, approximately 100 crore is our strength. We already beat the China. We are the number 1 in population. Do you know? I think, isn't it? Among that, 50%. That means 50 crore. That means 50 crore people are using smartphones, and their sensors are generating in such a way the data. Imagine the data. We have enough amount of data, but we are lagging with how to connect and then come up with a real product. This is what Sir worried. Guest of honor. We are senior worried. Easy. Develop new, cheaper, and more effective medicines. Longer lasting materials, predict climate changes for decades and so on. This is the purpose of the high performance computers, including supercomputers. Okay, so whatever Sir has mentioned, that was I included. Right, this is a small comparison between what's our standard computers and then what was the supercomputers. Our standard computers, sir, even we are dealing with quad-core, octa-core, etc. Sir, in our mobile it seems. You know about that, what is meant by quad, octa. Quad means 4 cores, octa means 8 core. Sir, which one is best, sir? So if you are going with more number of processes, it will kill your battery power. Even you are getting, you feel more amount of heat generated by your smartphones while you are connecting with the internet or external Wi-Fi's or internet sources. I hope you might have realized all this, isn't it? So, according to your usage, you should have come up with either you'll go for quad core, octa core, whatever it is. So then in our desktop computers, there is a number core i5, i7 families are mentioned, sir. How do we differentiate? We will buy that or get that machines, or we have to let's finalize our configuration. Is it that numbers are representing the number of processes? Sir, 5 means 5 processor, 7 means 7, i7 means 7 processor. It is not like that. Only the speed of the processes. Mainly, it's in 4 or even 8 core machines are there available. So only the differences, memory, cache memory size, and the system's clock speed. That may vary according to the crystal oscillator. I don't want to go for in-depth of architecture. See here, a single processor, multi-processor, single memory, multiple memories, less processing speed and execution, high processing speed and execution. Later on, I will come back to this right-hand side, because the left-hand side, you may might have discussed or studied your PG or UG, whatever it is. Measured in gigahertz. Here, the measurement is based upon flops, that is the number of floating point operations per second. So right now it's in MB or even it is it has exhausted more than that. Here, supercomputer means approximately 1,000 number of processors are connected, but right now it is reached up to lakhs. It's more than, there is thousands of thousands. So people are telling, sir, it's 1,000 number of processors. That is for an initial stage. Even in initial stage, 6 lakhs. There is 1 lakh to around above lakhs to 6 lakhs. Sorry. Right now, 7 lakhs number of processors are integrated together. You look at this. So it's an overview of supercomputers. High performance measured in flops. Already mentioned. Floating point operations and stuff, MIPS, millions of instruction per second. So this is for a normal computer systems measurements. I don't know how many of you studied architecture, computer architectures, particularly Hamden's law. There it is coming to the picture, millions of instructions per second. Here it is flops. Already I was mentioned that multiple cores when it exceeds thousands plus, that means thousands of thousands, lakhs. Housed in large clean rooms with a high air flow to permit the cooling, used to solve problems that are very difficult for standard computers. Suppose I don't know how many of you are doing currently research. There is scholars. Suppose your data is big data, more than MB, then the normal standard desktop machines are not in a position to run your data. So for that, you might have approached Google Colab or any GPU machines. Even though it was a GPU machine, it's very difficult to handle if your data is more than. For that, we need a Colab. Google Colab or such a supercomputing machine to handle such kind of data set. So that is a larger data set. Okay. It's an history of supercomputers. Just about the father of supercomputers, Seymour Cary, during 1960s, introduced the first supercomputer named as CDC, Control Data Corporation. 6600, 1964. It was in first supercomputer. You look at this image of supercomputer. Okay. Then developed in CTC 7600 in 1970. You see this Craven supercomputer projects started in 1972 and you see this finished from the 1974. Is that twice as fast as the 7600 with a vector speed of 80 flops per second. I told you about M stands for mega. 10 to the power of 6. 10 to the power of 6. Am I right? 10 to the power of 3 is kilo. 10 to the power of 6 is mega. 10 to the power of 9 giga, right? 10 to the power of 12 is petawa. Tera, right? Tera. Okay. We look at this, the Crave for 1990 supercomputers. You see this? 10, okay? Because if you go for this water-based or coal-based, it's more pollution and more hazardous than the nuclear. I'm not a mechanical engineer domain exactly what was, but I know the basics. If you go for constructing a dam, based upon that it will generate hydraulic energy. We have to concern about what if suppose dam will get collapsed, how many hectares of agricultural land and public living area will get impacted. That consideration you have to think and then occupying the land area. Of course, if we go for coal-based energy production, we have to get an approval from pollution department. How much coal is burned per day, how much ash will come out. Even already we have a yellow power plant. Computational fluid dynamics. Sir, where it is coming from? Fluid dynamics. Anybody is from mechanical? I think you know, okay, fluid dynamics. Even okay, exactly what kind of mathematical model which is okay used? Numerical methods are. So numerical methods are very much helpful in this domain of fluid dynamics. Sir, is it that numerical method is used only there is fluid dynamics, there is for civil and mechanical engineering? No, even in our human body. Even we will simulate our blood circulation using numerical methods. So blood also one of the fluid. Okay, so you know my seniors, okay, Professor Scholar, okay, then okay, the research and then there's fluid dynamics using blood okay, circulation. That's okay. Because of that only I know. Next one, weather forecasting and this is meteorology. So we have to be okay aware of okay in this particular domain to avoid the human lives and even Sir mentioned about disaster and other things. Aerodynamics research that is an extraordinary invention of engineering domain. What is aircraft? There, okay, you can go for simulations and then generation of data by the sensors in the flight. You know, there are okay, enormous number of sensors. Even okay, I mentioned the smartphone it seems has okay 10 plus sensors in imagine the flight aircraft. Right now, so everything is okay, okay, fully automated. Pilot is just okay, shifting the gears for landing and takeoff manually as per the system's instruction. Then how the system will there is come up with the conclusion based upon the high performance ATAS. So that okay, such kind of domain specific applications are okay, developed with the help of ATAS, real time operating system. Okay, that operating system is dedicatedly going to take care of domain specific operation. Flight, there is aircraft landing and takeoff. There's scheduling, then probabilistic analysis, stock market prediction, fraud detection, and credit cards, and even the financial sectors, etc. Then hardware, okay, we go for slowly hardware. See, you know about Moore's law in architecture. There's an okay law. It is dealing with the number of transistors and the integrated chips. Any idea about that law? In every couple of years, the number of this transistors sizes reduced doubler. Yes, get doubler, and even okay more number of transistors okay will be added into the integrated chips. The size of the chip is what okay Moore's law. Even you see the supercomputers of 21st century can use using over using lakhs processor. Okay. You look at this hardware, okay, screenshots of supercomputers, 1970s, 1990s, and okay, I think it's the 20th century supercomputers present. So I mentioned about massively parallel. Modern supercomputers are massively parallel. Sir, what is meant by massively serial and massively parallel? Any example? How come that terminology is massively parallel and massively serial? What is meant by massively serial? Can you give an example? One example is human brain. It's a massively parallel. Massively serial or desktop computers. Sir, can you justify? Yes. You come to the numerical computation, arithmetic. The computers are much faster. Even sir, we are faster, sir. Yes, human being also faster if the number of digits are restricted. Okay, both multiplication and multiplier are smaller size. That is 2 digit or plus 3 digit. Okay, sorry. Worst case 3 digit. We can. Suppose it's in 1, 2, 3, 4, 5, 6. In terms of 7, 8, 9, 10. That's multiplication is very difficult. But the machines are able to compute the multiplication of the numbers and much faster than us. Due to massively serial. It's dealing with bits, bytes, words, everything. So it is even serial, parallel, those bits representation. And sir, you mentioned about massively parallel. It means for human brain. So simultaneously, the human brain is computing the information through all our peripherals. That means senses, eyes, ears, nose, also our skin. So our skin is predicting what is the weather condition or temperature of the flops. Previously 80 megaflops, now it's 10 megaflops. Just in the 1990s supercomputer. You see this? This architecture is a continuity. Already mentioned about there is two major types of supercomputers, namely parallel systems and distributed systems. You know the generic meaning of what is meant by distributed, isn't it? The distributed systems are otherwise also called as loosely coupled system. The reason why is the distributed systems are connected via network, LAN, WAN, like that. Each and every individual machines has its own clock frequency, own memory, own operating system. And the task is divided into multiple number of subtasks, and it will be spread over to the entire distributed system environment. Each and every machine is going to individually manage and control those subtasks. Sir, then who will coordinate and manage those divided tasks? It becomes a master system. One of the system is going to act as a master system. That system will coordinate and manage those subtasks. So then, what is meant by parallel system? Parallel systems are tightly coupled system. All the processes are connected within the single system environment. For example, exactly supercomputer. Another alternate method is distributed computer. Distributed computer means we are connecting all our lab existing systems through the LAN, and we are making utilization of those machines by dividing our whole task. I think you know the difference between concurrency versus parallelism. Isn't it? Concurrency, yes, a single CPU is more than sufficient to achieve multitasking. That means running multiple processes, multiple tasks with the support of contact switching. But in parallelism, there is no need of any contact switching, but we need a multiple number of CPUs. There's a basic difference between concurrency. Anyway, concurrency adapts somewhat parallelism in the job execution, but with the support of contact switching. You know what is meant by contact switching and everything. I think we have studied in OS. We don't know for in-depth of OS and architecture. But the supercomputers are fall in the parallel system. Now we are very clear about how come this supercomputers, which category it is belongs to. There is a high performance computers are broadly classified into distributed system and parallel system. Among that, the parallel system incorporates supercomputers. Again, the parallel systems are broadly classified into 4 types according to the Flynn classification. I think I'm boring. Actually, basics are very much important. That's why I'm connecting everything step by step. If you have any clarification, sir, I studied this article or this subject like this. What way it is related to this topic, or how can I connect that topic? Please stop me and share your all this thought or queries and text. No problem. I give your interaction. right? So according to the Flynn classification, there is four types of categories. Then the recorded voice, text message, whatever you send, that will be provided by the concerned service providers, BSNL, ATAL, Geo, etc. Do you know that? So how much you people are very closer to technology, that much you are losing your privacy. No doubt. Even with my modification, that is not at all possible nowadays because of the fastest moving world environments. Now what is the need of? Okay. Even family also. Right. That is the only option. Anyone, nobody knows, sir, I'm going to delete I deleted already. Even 1 TB of information I stored, the chat history, everything I said, sir, now I deleted. We will require it back. That entire content of hard disk or memory card or any flash memory. You have to be careful about handling all electronic form of particularly dealing your personal information through your smartphone, particularly in social media. Any idea about AI part? Right. Only that is if you are uploading your social media, that is through your social media. If you are uploading images, there is photo, something clips with new AI. They will generate all possible combination of new pictures. There is a separate network. It is dedicatedly available. Please use it for ethical. That is it's an for positively and commercial purpose or research purpose. Don't misuse it. Technologies can kind of an two-edged knife. So if you are hitting in one direction, automatically it will give you in another direction. So take care. So ethically, how to use it. That's why I never explored AI related content in depth. Okay, so everything is available. With AI, you can make it. Even WhatsApp introduced one chat GPT. With that, you can even though you was not there in that particular location, if you are instructing the chat GPT, then it will collect your images as per your permission. It will map those images. For example, right now I'm in your campus, but I want to make it as a picture of currently I'm sitting in Marina. Okay, it will generate all those images. You know that? Please, you have to aware of all this. Please, don't share your pictures, personal information. Don't continuously keep on change your status. Okay, that's why I never using such an social medias in a frequent manner. Most of them are using it as very frequently. I'm here and that hotel I'm having lunch with the XY. So take care, that will going to affect your privacy and then security. Don't share any personal information. My favorite pet. Even maybe a password of anyone of us. So take care. Right, you come to the one example. This is what I want to inform regarding Shaw algorithm. Shaw algorithm, currently it is used in 256-bit representation. It will take hardly 50 years to break that encryption by the standard systems. Even if we use supercomputers, it will take hardly 25 years to come up with the original message. For example, my name is Selvakumar Kamalanathan. If it will be encrypted by Shaw algorithm of 256-bit, it will take 25 years by the supercomputer itself, even though it wasn't much faster. But the quantum computer will decrypt that message within a fraction of a second. Then imagine the speed of the machine. Fraction of a second. So those machines will come into the picture. So our privacy and security or question mark. Even we people are dealing with artificial intelligence, isn't it? Most probably in 2030, nobody is going to use AI. The master will come into the picture, super intelligence with organizing intelligence. You might have seen the Rajinikanth robot movie, right? Indiran, such kind of humanoid robots are coming to the picture. What will happen though? Okay, if, those kind of machines will come into the picture. Already, most of the private universities are introduced AI robots for handling the classes. Not only for our jobs, that is teaching. Everywhere else, it's a question mark. Even such kind of robots are very genuine. Right? Even we people are sometimes make a one-side decision. Okay, you imagine that property was called as rational property of agents. I don't want to go for it. But you see this quantum entanglement, how far it is reflecting, and a spooky action at the distance. That is how far that energy intends to describe the entanglement of see spooky action at the distance. That whatever I mentioned, the speed of the quantum computers, right? Waves and multiple waves and its possible combinations, permutations. See one of the examples. You want to invite five your close friends to your wedding. Then total number of weddings. You want to make a seating arrangement of your five friends, your wedding. 5 factorial 120. If the classical conventional computer system tends to evaluate each of the 120 possible combinations, compare them and decide on the final optimization which kind of seating position is. You see this, however, the quantum computer undertakes the following steps. Considers qubit and creates quantum superposition for all possible quantum states. See this? And second step, you see the encoder. You know what is meant by encoder? Encoding and encryptions are different. Encryptions, it converts original plain text to ciphertext. Encoding is replacement of, that is, it's like a telegram, something. Instead of a character A, it is going to be replaced by something. They call it as encoding. Okay. There are different types of encoding. I don't want to go for it. It is going to perform encoding and other things. The quantum computer then uses interference to reinforce or amplify some answers and cancel or diminishing the others. That means the waves already mentioned, amplification of waves, and which one is the strongest and the superposition approach that is going to be and the final solution for optimized seat allocation finally reached. We have discussed about so many optimization techniques, swarm intelligence, honeybee colony and colony optimizations, local optimization. Okay, like that it will come up with the solutions. The quantum computers take up a fraction of the space of classical computers already mentioned. A level of the power that can find a solution to problems out of the reach of today's computers. Yes, already mentioned the power consumption of the supercomputers, but it will take less power by decreasing the size of the transistors. We are gradually approaching to the atoms stage, beyond which we can't move down except applying the quantum mechanism. Even transistors, we already reached. We cannot reduce our chip size. It's much smaller. Whatever it is exists as per our usage. But if we go for atoms, we can reduce even 10 to the power of -6 nano. Even you can insert to our veins and everywhere else. Human body too. See here? is whatever I mentioned. It is a few things. There is a classical including. You see the interconnection of the small quantum computer.
யார் ஃபோனில் எடுத்தீங்க?
என்னம்மா வீடியோ இப்போ வந்து டெலிவரி
இல்லைடா கேமராவில் வைக்க வேண்டியதானே?
கேமரா கீழே எடுத்துகிட்டு வந்துச்சு கேமரா.
This is a transistor and it's an second one is hard disk is a long term. I don't know how many of you map and studied those concepts, this RAM and hard disk related concepts. Only the problem was, from our side is mapping. That's why our faculty members are insisting you people to take a hints classes. You know the result of keeping the system in ideal condition. What will happen? It will go to sleep mode without providing any work to your machine. That means if your system is in ideal condition, obviously it goes to sleep mode. Okay, it is applicable to human brain too. That's why your faculty members, your guides are insisting you to take a piece. Okay. And regarding operating system, you know the definitions and the major functionalities of the operating system. Sir, what is this? Okay, lightweight kernel. Kernel is a part of the operating system. The modern operating systems are coming with lightweight kernels. It's keep on running in the computer machine, and it is going to control the layer of the rest of the functionalities. OS. That means directory, file management, memory management, scheduling, protection and security, etc. So all are controlled by this kernel, part of the operating system. You know why that kernel was compared with heart, right? I don't want to go for art history and other things. You see this? The compute the nodes using this lightweight kernels. But larger systems such as Linux, derivative to on server and IO nodes. Even a very good example regarding this lightweight kernels, Ubuntu and other Linux versions. You can refer it. Already I was mentioned about this word, computing. It's a field of system right now. So you see processing power of large number of computers in distributed form, and diverse administrative domains is used whenever computer is available. Already I mentioned about what is meant by distributed system, how for it is function. It's an interconnection of individual autonomous group. Even it is called as loosely coupled system. The distributed system or other is also called as loosely coupled system. Next, we look at this parallel systems. Massively parallel, also known as tightly coupled system. That means you see this large number of processes are used, close proximity to each other. That is computer cluster. The system, you see this massively parallel system, the speed and flexibility of the interconnect becomes very important. The modern supercomputers have used various approaches ranging from enhanced infinite band system to three-dimensional you see this torus interconnections. You know about processor bus connectivity, SCSI and etc. There is memory connectivity, then memory sharing of this. There is lakhs of processors. I told you about this parallel system has common main memory and individual cache memory. So individual cache memory is like an accessing of attached registry. Accessing at common memories, it's an accessing and common public. Then imagine the traffic. So it is using, you see this torus interconnections, high speed connections. among the processes. You look at this, the diagrammatic representation of clusters. Actually, the cluster computers are two or more computers working parallel to achieve the greater performance. Actually, this computers greater work among the computers in the cluster. That means already I told you, the whole work is divided into subtasks, and each and every system, the cluster, will take care of each and every subtask. You look at this. The clusters, okay, the computers in the clusters. Okay, CPU itself with its own processor, memory, and hard disk. So the computers communicate with each other and interconnecting process. That is called as cluster. Distributed means separate systems. Sir, here all the processes are in single logic system, but only the bus is differentiating the bus connectivity is differentiating this processes. Connections. You know about the architecture of topology, network topology, star bus, then hybrid, etc. Similarly, the connecting technology of processes are so different. So multi-processor computer has two or more of the CPUs. Whereas 1 decade back or 2 decades back, a dual core processor was introduced. It has in the two processes. Right now, we people are using Core i5, i7. We already told you, it does not mean that the number of processors are 5 or 7 respectively. It is more than that too. Even it may be 3 processor units or 4 processors, but that was named as Core i5. Only that memory, I think L1, L2, L3 cache memory and its architecture, interconnectivity. Even any idea about multiple architecture and Harvard mark? Yes, otherwise also called it as stored program concept. Thank you, sir. Then what about another one, Harvard mark? Separate memory for both the instruction and data. So what kind of, which kind of architecture-based machines are we using? One human is enough for desktop computers. Whenever we go for such kind of high-performance computing, that means supercomputers or high-end machines, we need a Harvard mark. Single instruction, single data, or multiple instruction, multiple data. This you have to interconnect. So this is another 2 major architectures. So each processor is capable of running different programs simultaneously. That is multitasking. I mentioned about concurrency, multitasking. More than one task with the support of context switching. But in multiprocessor environment, it is different. Parallel execution, we need multiple processes. In operating system viewpoint, we might have realized about all this multi-programming, multitasking, multi-threading, and then multi-processes. Even the examples, real-time examples too. I don't want to go for OS viewpoint. Then you see this multi-processors. The CPUs all share the other parts of the computers. That means common memory, the common hard disk, bus, everything. CPU communicate via memory and system bus. So architectures I was already mentioned. Cheaper than the cluster computers, but does not perform well. Why means we have to go for parallel programming. Right? Even though we have a multi-core architecture environment in our system, we are not using parallel programming as much as possible, because we are using sequential programming methods. So that we have to go for parallel programming. So, how do we learn about parallel programming? That is any idea about OpenMP, MPA? I studied about MPA, message passing interface. It is concerned with parallel and distributed systems. Simply parallel computing. So please you can refer parallel computing. regarding MPs, message passing in MPs. This is one of the concept. Another one is open MP. Open MP, that is open multi. Actually, this open MP was combinedly introduced by IBM and some multiple number of chip designers like an Intel, everyone for their the fastest execution of the programs. Any vendors or any user. So yes, right. We have to focusing on this how the systems are performing well. So for that we need the software programs, algorithms, parallel algorithms and everything. So there is 500 plus supercomputers are exist as of now, more than 500 plus. Among that, these are all the top 5 ranked supercomputers. The first one is Frontier, second one is Aurora, second one is Eagle, and you see this fourth one, Fugaku, and last one is fifth one, Lumi. So what way these supercomputers are ranked according to the speed of execution, the number of processors. Obviously, the number of processors are varying among this. So among these 5, the first one I am going to explore here for your understanding purpose. Rest of the things, please you have to note down and Google it. You will get to know the configuration details. Okay. So if you look at this, the latest, that is according to the 23 and 24 survey, this supercomputer Frontier is in number 1 system. The location was, you see, Oak Ridge National Laboratory. Tennessee, US. System model HPE, Cray, Exascale. Systems configuration vendor, Cray Corporation. Installation here 22, and according to the 23 and 24 survey only, this supercomputer was ranked as number 1. Linux OS, processors AMD. You know the different types of processor manufacturers. AMD, Intel, they are the major contributors. Even NVIDIA too, Fairchild, Motorola, but they are not contributing that much in the field. Right now, Intel and AMD is the competitors. You see this AMD processors. You see this 64 core CPU, 64 processor in each and every chip. Because such a computers are having lakhs of processor units. See here, and you see here 64 core 2 GHz CPUs, and you see this how much? 6 lakhs 6,208 cores. And the other features of Frontier supercomputers, Cray XT computer system. You see this 595 petaflops. Previously, mega and giga, tera also reached right now peta. Peta 10 to the power of 89. Yes, 10 to the power of 80. You imagine the speed. System memory 362 terabytes. So you see this processing cost 6 lakhs 6,208 dollars. It was already mentioned. See this other input output bandwidth reading writing of files 284 gigabytes per second. Imagine the speed. Just if you are touching the keyboard, everything will get over. Imagine your memory. That memory must have the ability to store the downloading data. Otherwise, the system will get hang. So high speed, greater performance, high data transfer rate, high system memory, everything is an advantage. Disadvantage. Yes. The human inventions has both pros and cons. So then, which product has only pros? Only God's creation, right? requires large area, very costly. You can see 600 millions are invested. Even it is less than a Chandrayaan-3 project amount, I think so. Required more electricity is 30 megawatts. Any idea about power consumption of ChatGPT? Because people are very frequently using, isn't it? And nowadays, students are very happy. Whatever the assignments, what is it? Okay, even they doesn't bother about the complication of the assignment. Only faculty side only we are bothering. If I'm hosting the assignment question today in in department portal, next day immediately in the morning while I'm opening a portal, my students are uploading the assignment. Sir, with the help of ChatGPT, we have done, sir. Within 1 hour. So, right, okay, that is okay. Anyone is imagine or thought about the power consumption of the ChatGPT? Here it is approximately mentioned 30 megawatts. Any idea? Suppose if you are throwing one query to your ChatGPT, that is ChatGPT, how much power it will consume? It's an megawatt only, more than 1 megawatt. With that, we can provide electricity to one small village, but whole day. Then imagine the power consumption of supercomputers. Only we are bothering about power. Even that area also not at all matter. Then imagine Google servers, search engines, Gmail, each and every Gmail user, account holder. Google is providing some amount of space, isn't it? Some GB. Then imagine their equipments, hardware, setup, power consumption, everything. Imagine. Yes. Soon we are going to face that is hike of electricity bills. Yes, because the usage of electric vehicles, electric utilities are more, including computers. Okay, because we people are adapted to such kind of environment. Everything becomes instant and smart. We don't want to use our brain. Okay, we want to use others. That is machines. That's why we are facing all these issues, isn't it? Yes, we are not ready to use our brain. Even our former presidents, I know only this information. APJ's brain usage is 0.00000. Then you think about us. Even we will include more another 10 or 50 digits 0, and then we'll put 1 also. I don't know, including myself. That is the usage of our brain is very less. We are using this. Okay. Come to the topic. Some of top ranked supercomputers. Additionally, HP cluster platform, dual Intel Xeon. HP slowly is coming to the picture with Intel. Previously AMD architecture. Right now it's Intel is combined with HP and performance 188.7 tera. Previously Peta. Other examples, IBM clusters, Param clusters, etc. Even this is then one of the supercomputer from our in my institute existing machine. It was funded by CTAC. See this, the total number of nodes, master nodes, login nodes, everything. See here. You know the meaning of Param? Actually, nodes are fixed. That means it is going to take care of the entire control of the machine. If one will goes failure, another master node will leaves. There is no election kind of things because here the number of processes are restricted, not lakhs. I think it is okay. It is lesser than lakhs. Greater than 1,000 number of processes. So no need of that's dynamic master nodes. It is fixed everything. Okay, chief guest also one of the member in this peripheral installation process. Then CPUs 75 and the number of GPUs are 32. It was restricted. So previously we had discussed about Frontier. Frontier has around 6 lakhs processors. But here it is not that many number of processors, so that it was restricted as it is. The afternoon, if the problem is rectified, then we will demonstrate using this param. I asked you about what is meant by param. What is meant by param? Any idea? The meaning of param? That is a supercomputer of India design. All supercomputers existing in our country is called as a national supercomputing machine. It is controlled by CDAC. So sir clearly said about the data information wherever it was. Even there is such a miscommunication between the IT department and the MHRD. Everything is there. Anyway, so I'm going to play one video clip. This information regarding this param. So this is an information about param, clear information. How many number of nodes and clear information about supercomputers, master node, what is the role of master node, what is the role of logging nodes, everything, right? Architecture, everything is separately given in this PDF, introduction about this, system architecture and configuration. So from this document only I took all the information, the services, CPU computing node, GPU configuration, NVIDIA and Intel mixed together provided this storage, 1 petabyte primary storage throughput, 25 gigabytes per second. OS again everywhere is Linux and CentOS OS version 7.9. This is an architecture. You look at this. Those Frontier and worldwide supercomputers doesn't provide such an architectures. This is for your understanding purpose how far those nodes are internally connected and controlling with each other. Look at this. Okay, that red color indicating a firewall. So you know, right? That's what sir asked. What about the status of this supercomputers? As of now, we shared credential to all our scholars. Even myself, in my research lab, I'm using the supercomputer for processing the data, which is gathered through sensors, industrial sensors. Actually, my current research is under domain of precision agriculture, collecting the sensors from the real-time locations, that is agriculture field. From that, we are collecting information like NPK, that is soil NPK components through these sensors, and then wind flow, wind direction, rainfall, as well as the particular location, humidity, when soil conductivity, electrical conductivity, and then soil pH, everything. Even what way wind flow, wind direction is affecting the crop yield. That is what the data which we have gathered through those industrial sensors. Actually, that was in separate slide. In particular case, sir, if you are suppose if you are collecting this particular location in the agriculture field, even we are kept that sensors in our institute, that is inside of the institute for safety purpose. Then how will you calculate overall Tamil Nadu and each and every district? So for that we are collecting the data set from Tamil Nadu Agriculture University and we are cross verifying. Even it is very difficult to come up with the conclusions. So that we are planning to go for drones for capturing large variety of covering the large areas through image. So as of now we are gathering the data in the form of numerical. Okay, so we are planning to come up with a new idea to image, SAR images kind of things. We want to cross verify. So overall countrywide we have to gathering the data and fixing all these NPK components and different kind of crops. Here in Tamil Nadu, you know, particularly paddy and banana. Yes, Kaveri Delta, yes. Yes, obviously. Actually, the Kaveri River water has such a quality. With that only, the people are cultivating paddy plus banana. There in Tiruchi, it was even sugar cane, everything. So apart from this, in Erode, turmeric kind of thing. So we have to verify that particular soil and the water, the pH and everything. We have to come up with the right decision making, and it will be very much helpful to the farmers. No need to pay and through these their smartphones, they are capturing the image and they are uploading that image to the particular app whatever we develop. Then it will classify what kind of disease and due to what is that component was majorly affecting that. It is a prediction of regular research. Even at that sensors are still regularly every day, every hour we are taking the data. Previously the testing condition every minute we are generated, but we don't have that much of storage capacity, so that we have started. So every hour it will generate all those sensors, pressure sensor, moisture sensor, temperature sensor. That is NPK, all are it is comes under one sensor. That is NPK plus soil pH, soil moisture. 5 data that will be generated by one sensor. Then one more sensor, it will taking care of the particular location, humidity, and then pressure and rain gauge, and calculating the fall of the rainfall, amount of rainfall, and then wind. There is another sensor taking care of wind flow, direction. So we are using both electricity power, that is electrical power, as well as solar power. Continuously we are running. That the PPT also is there. This is one of the application I'm telling. So those informations are processed, and that computing nodes will take care of all those things, and login and other rest of the directory creation managements are handled by the login nodes and other things. GPUs, computing, large data related operations. Okay. NPT components, the wind flow direction, wind direction, everything. So, it is going to design of sensors, industrial sensors. So through that, through LoRa, these sensors are connecting with my cloud server. It is hosting the data.
Increase focus.
Right. So with this, I'm going to stop about supercomputers. So next, we'll go for quantum computers quickly. This topic I'm going to wind up. Any idea about quantum? Which domain actually this terminology is from? Physics is obviously, thank you. So the computing technology is completely depends upon the concept of quantum physics. Any idea about that? Quantum. This is what is that? Famous scientist Max Planck, father of quantum physics. Quote. With this, I'm going to get started. When you change the way you look at things, the things you look at change. Changes permanent. You see this? The quantum computing is an area of computer science that uses principles of quantum theory. Before I'm going to discuss about all this, first I want to give some uninformed information about the difference between the modern systems, including supercomputers and then quantum computers. Okay. It is applicable to supercomputers. So all those existing computers are using bits, binary information. The bit levels are either 0 or 1. So what about the quantum computers? Yes, obviously more than two states. And then these computers are using quantum bits. That is called it as qubits. Sir, what is the difference between qubits and everything? We'll go for it. The qubits are not only in either 0 or 1 state. It will be all the states, either 1 or 0 or combination of both, anywhere. So, sir, what is this specific technique or specific logic behind this superposition theory and permutation and combinations are applicable. We'll go for an example and possible information about all possible information about the qubits. That is what mentioned here. The classical and the modern computer systems using bits. It's either 0 or 1. Okay, you see this, the qubits. This is an situation 1 by do that is square root of 2. Okay, you know the mathematical notation of this. You see this? Unlike in classical, it's a linear combination of both the states too, or whatever mentioned. Not only 0 or, it's in all the states. Sir, and how do we identify superposition approach? Then imagine the speed of the system, even okay, for your understanding purpose. Idea about tuning fork? Tuning fork? I think physics tuning fork. Just you are hitting on one rubber ball and you are hearing the sound, okay, vibrations. That is frequency, even for your understanding. Waves it is okay, generating. Instead of okay, bit levels or the massively serial okay, approach, the quantum computing techniques are using sequence. Okay, frequency and sequence. Here we'll go for some video clips how for a test process. Then there are possible combination of sequence. From that, it will apply a permutation and superposition approach. It will come up with the solutions. We look at this, the classical bits either 0 or 1, but Q bits any level. You cannot say that bit was in 0, bit was 1 like that. Any level or okay, combined together. You see here, it's a classical bit representation. See, either 0, 1, whatever it is. So 2 to the power of n possible permutations. But here in quantum qubits, both 0 and 1, all 2 to the power of n possible permutations. Okay. Again, all of 2 to the power of n possible okay permutations. Here, only 1 out of 2 to the power of n. Only 1. But here, all possibilities. 2 to the n okay power of 2 to the power of n possible combinations will be considered. Okay. This is an okay short evaluation of quantum computing. Here, the second person, David okay, Lutich is the father of quantum computing. He only invented a machine based upon okay quantum Turing machine. In our computer science and engineering domain, whatever the okay products, either it's in hardware or software, which you are implemented newly, that must pass Turing machine or Turing test. Until otherwise, your hardware or software will not be recognized. I think you know what is going to be Turing test. I don't want to before it. You see this that inventions and contributions of different scientists and different eras. You see this quantum superposition I mentioned. If you look at the light source, is one of the example. When you are reflecting the light source on the metal sheet, you see how the waves are reflecting. This is a small understanding of how the quantum computing has an enormous speed. Even okay, I'll give you an okay example too. Now it seems. Any idea about SHA algorithm encryption? Nowadays, you people are using SHA-256 in blockchain technology, isn't it? Any idea about encryption algorithm? Encryption. For securing our data exchange on the internet. Even if people are using SSH, HTTPS, it means secure. Even for your simplified form of understanding, whenever you are opening any internet bank website of different bank, whatever it is, while you are typing username and password, all those informations are encrypted. For example, your name, for example, my name is Selva Kumar followed by Kamalanathan. This was my SBI personal account name. Then while I'm typing my account password, those informations are encrypted. So in between, no one get to know about it. Even WhatsApp, you people are looking at end-to-end encryption. What it means? No one in between look at what you are sending and sharing to your receiver side. That is the person who is very close to you. You don't think that, so no one knows. If anyone is thinking, you are not. Okay, sir. these are the three various types of quantum machines. Quantum annealing is again it is followed under physics. Annealing, then quantum simulation and universal quantums. It's a type 1. Quantum annealing is the best for solving optimization. There is local solutions. Look at this. We use Volkswagen already approached in China, particularly in Beijing city, for predicting and reducing the traffic and free slots of parking and other things. The second one, quantum simulation. Actually, the simulation exposes specific problems in quantum physics that are beyond the capacity of classical computers, simulating complex quantum phenomena. Some examples we see this: condensed matter physics, high energy physics, atomic physics, quantum chemistry, and cosmology. And even we see here gene related gene to gene, protein to protein interaction, protein to drug, I mentioned in the medical domain. The third one, universal quantums. Actually, these kind of computers are you see, most powerful and most generally applicable, but also hardest to build. See this? Lakhs of qubits are used. So the drawbacks, algorithm creation. There are some specific algorithms. Dutas algorithm, then Shor's algorithm, then Siemens algorithm, followed by Fourier checking and other algorithms. The low temperature is required, not open for public, also internet security also. There's organizations who are dealing this quantum computing research, IBM, DVA Systems, Google, Microsoft, Rigetti Computing, and IonQ. So the conclusion of the session about the supercomputing roles, the power of the supercomputings, the components, the energy consumptions, application areas of the supercomputings and its major classifications and its main applications, etc. And also I wonder with the supercomputers followed by quantum computers. What is the use of quantum computers and everything? So with this I am going to start. Many clarifications. In the afternoon session, just I am going to give an basic Linux comments of supercomputers. How do we access supercomputers? And Windows and Linux based environment. And check if the machine is ready, we'll go for directly supercomputers. Otherwise, we'll go for Linux and then followed by supercomputer related commands and everything. I'll share my PPT with you. You can practice and then come up with your program execution according to your data set, and you create an environment variable, how to activate the environment variable, how to run a code, except everything I'm going to demonstrate in the afternoon session. So before that, any clarifications? Well, how do we connect all those very hot keywords like A, ML, data science with this high performance? Sir, you left out one important keyword, machine learning. Machine learning, if your data set is very restricted, then the data set based features are manually extracted, that will be fed through the code. But in deep learning, if the data is big data, the deep learning models are itself, it will identify the features like a low level, high level, medium level. I hope those who are implemented are realized. Yes, sir. Actually, generic processors, that is computer side, that is a processor is meant for generic purpose like programming and gaming and everything. Even their cache memories and their interconnection architectures are different. That is, even in system memories, L1, L2, L3. But in mobiles and all, there is no such kind of memories. Even there is no hard disk concepts. So all are in ROM and RAM concepts. But in general, Desktop computers, there's on the secondary memory and then primary memory. Even clock speed and even power consumptions according to our usage of apps and everything is lightweight. OA is also dedicated, but our operating systems are general purpose. Whatever the device is, which are inserted, that will be identified with the corresponding device drivers are installed, everything. But in our smartphone, it is not like that. Everything is built in. Those drivers are installed. Even memory also restricted. Only inbuilt memory, that is people are telling 64 GB or something. With that, it is going to act as both ROM and RAM. No, the hardware is restricted. Power is, you imagine the power. Even 24/7, if you are connecting, your smartphone through internet and your Bluetooth, Wi-Fi, that is, what will happen? You imagine the battery, how much it is consuming. You imagine if you are trying to convert your smartphone as an super smartphone, it will consume more power. But it is restricted with the clock frequency and even it is memories are very less. Cache memory is very less, isn't it? But in the system side it is enormous. 3 levels, L1, L2, L3. But there is no such kind of architectures are used in the smartphones. That's why, whatever the feeling, people are approaching the desktop machines, we won't get the same feeling while you are using smartphones. Only for time being, sending short messages, mails, replying the our internet communications, we people are using, but not permanent. Like us, hard kind of what is multitasking, playing gaming. Even mobiles are helpful, but battery power is that's a factor. Plus wide screen and other things. Even all-in-one PC providing all those whatever you are asking, touch all the mobile-based things. But you can execute only small kind of database executions. RAM is restricted, right? So you cannot go for a bigger database execution. Possible through online compiler, you may go for it, but as per the RAM restriction, we cannot go for bigger size, larger database. The conversion of your smartphone to that is super smartphone is what is difficult. Right. Any other queries? Sir, as of now, every department, they are using scholars. Through their scholars data set, they are coming with some applications, not only from CSE and even civil department, particularly structural engineering and mechanical department, particularly production engineering, they are using. So my scholar also working in protein to protein interaction. During Corona period, it seems she collected the data set. So what kind of medicines are those things and all, protein to protein interaction. Particularly she done clustering, grouping of similar proteins and everything interaction. For that, she used. Yes. Execution purpose. Dealing, collection of data, that is taken care by local cloud server. Suppose the data is more than GB, for 1 year data I want to process, I need a yes, exactly. Yeah, obviously. We are planning to use deep learning instead of machine learning. So the deep learning model only we are going to propose. Even all those models are used so for half of the decades. So we are planning to go for some contribution on that basis. Yes, we are. We are not getting that kind of very good scholars from open Italy. It's very difficult to manage them. I don't have enough time to sit and do research like when I was in a PhD student because of administrative activities. I'm hoping otherwise we will even I will get a very fruitful outcomes in the publications. Anyway, I'm getting publications, but the thing is that the lagging of experiment. Without experiment, we cannot go for transactions or that. So they are even I find it better as a
கொஷின் கேட்குறவங்க தரது கேமராவே எடுத்துகிட்டு போயிட்டு ஷூட் பண்ணாங்க இப்படி பண்ண முடியாது அப்புறம் நாளைக்கு
பண்ணலாம். இது ஏதோ டைட்டாக ஏதோ பிடிக்குது
தம்பி நாளைக்கு எதிர அதாவது இப்படிடா
டேய் அது எல்லாம் பண்ணாண்டா.
ஓகே
இதுதான் இப்போ
இதை யூஸ் பண்ணிட்டு இதுதான்
we are ready to show. And that's what sir asked, okay, how much percentage of the systems, what is the outcome? We are ready to show. Particularly for projects, those things will come up with MOUs. We are freely providing this.
வீட்டில் வச்சுட்டு அந்த அண்டர் கோர்
As of now,
அதை வச்சு
NIT people are using free. So it is okay.
ரிலேட்டிவ்
Yes, you can come up with MOU.
ரிலேட்டிவ் ஏதாவது தெரியும் அந்த
That's why
ஸ்வீட் கம்பெனி
we
அது சொல்லிட்டு
are institutes get this through MOU.
மலையாளமா நீ மலையாளம்
Even data.
வேர்ல்டு மேம் ரிலேட்டிவ்
I'm ready to share my data.
ஃப்ரெண்டு ஃபேமிலி ஃப்ரெண்டு
Still it doesn't know. Verification stage. Once it will be limited or more number of operations or researches are made up of the data, it will be proved as a benchmark data. Then immediately we will be take it in research. No problem with that. It's knowledge sharing. I'm always welcome. Ready to access. Any other clarification? Any future collaborations? Please, let me know. Okay, thank you for your patience listening. The first slide is email ID and the information about the access.
யூஸ் பண்ணுறது அர்ஜென்டாக கேமரா யூஸ் இல்லை யாரும் பார்ப்பாங்க அப்போ வீட்டில் போட்டால் பார்ப்பாங்க
So what about the email for your research? Thank you all the participants for Thank you.